I'm going to be talking about Trustable AI, which is sort of a bit different, I guess, from what everyone else has been talking about on silicon verification. Bit of a left field thing, but never mind. It's a change. So my name's Gareth Richards. I'm the AI network manager at TechWorks-AI, and just a bit of context. My background before joining TechWorks was in electronic payments for about 30 years. So a lot of what previous speakers have been talking about sort of rang true in terms of roots of trust and PKI infrastructures and all that sort of stuff. And a lot of it's very interesting. And I'm going to catch up with them later to talk about that. Just a quick bit about TechWorks. So TechWorks is a non-profit industry association. We've got members from across industries, really, from British Aerospace at one end through to founders at the other end, single-person founders, a lot of UK universities. And what we do really is get everyone to talk to each other, get involved in collaborative projects, and do good things. So some of our members are people like this, so everyone from Arm through Jaguar Land Rover, Thales, and a lot of semiconductor companies, of course, as well. And what we do is do things like this, networking events. This obviously together with TESOLVE. We do cross-sector collaboration. We get involved in industry strategy and advocacy. So we've got quite good links into government, into DCIP, DBT, NCSC, people like that. And we formulate best practice and open standards. So that's a bit about TechWorks. But to get on to the subject of trustable AI, and I mean a lot of talk about trust today, trust, roots of trust, and various things. I talked earlier by Andy was talking about, how can we trust what your AI EDA system is doing? And a speaker from Silicon Catalyst basically said that you shouldn't trust it at all, which I found quite interesting. But anyway, we've been working on this project with British Aerospace, BSI, Copper Horse, who are an Inquiry Minds, who are both TechWorks members, and the University of Oxford. And this project is all being around versioning, attestation, and integrity in AI bills and materials. So it's sort of about software bills and materials, really, and applying that to AI systems. But at first, I think we should probably have a quick talk about trust. It's one of those terms we bandy about quite easily, whether we trust something or not. What is trust? So Vodafone, for instance, might trust Cisco in their network infrastructure, and conversely, China Mobile might trust Huawei in their network infrastructure. But the UK government said Vodafone really shouldn't be trusting Huawei. The US government had a similar opinion, but likewise, China Mobile may well not trust Cisco in their network. So it's a very subjective thing. I quite like this definition of it. So it's the willingness of a party to be vulnerable to the actions of another party based on the expectation that the other will perform a particular action important to the trustor, irrespective of the ability to monitor or control. So you have to sort of let go a bit and say, I can't necessarily monitor or control this, but I'm going to trust this entity anyway. And that might be a good definition of trust, but it's not perhaps necessarily what we really want to do. Perhaps we do want to monitor and control. So this brings us on to soup, obviously, and in particular, this can of Amy's soup. So Amy gives us some. Amy's give us some provenance information. They tell us that this can of soup is made by them. They give us some attestations as to what's in their minestrone soup, and they give us an integrity guarantee by putting it in a can with a lid on it, so that we've got a fair chance of knowing whether it's been opened or not. And maybe these attestations about ingredients, we can have a good go at verifying those, right? We can probably find a kidney bean in there somewhere. We stir it around a bit, find some peas. We might be able to, find other bits and bobs in there that we recognise. But they also say that it's got 50% less sodium than their other soups, which probably a bit less easy to verify whether there's 50% less sodium in. So we're starting to take this on trust pretty much already. And then they make some provenance guarantees about their ingredients. It's organic garlic. Well, we as a consumer have got absolutely no way whatsoever knowing whether the garlic in their soup is organic or not. So we're taking that absolutely on trust. And we do the same thing in software, of course. So we, XYZ Corporation, we might trust, and therefore we've got perhaps more, faith in what they say about what's in their software. They might tell us what's in their software. We may or may not be able to verify that. They might make some integrity guarantees for parts of that software. Perhaps they'll give us a hash of it or a signed hash, even better. And they might give us some provenance information. This, this component was made by this company. And that leads on to software bill of materials, which is, where the industry is moving for lots of reasons. But even if you've got a software bill of materials, did you write all of the software? Probably not, almost certainly not, right? You probably pulled in a library from here, driver from there. Where did those come from? Do you know? They're in object format. We do know they're all vulnerability free, or we might have some CVEs from various suppliers of those saying that these have been fixed. Can we prove that? We probably can't prove it ourselves. And the reason this is going to become very, very important in the future is that in particular, the EU Cyber Resilience Act is going to insist that products and connected products, digital products they call them, so that's pretty much any product you're going to put on the market, must be accompanied by a software bill of materials. So that is in the same way you have a technical construction file now, which says, you did the radiated emissions testing and you did the safety testing and all of the other testing. The market surveillance authorities might say, oh, where's your software bill of materials? Because we need to verify it because we've had some incident that has caused the problem. And when you put the product on the market, it also must have no known exploitable vulnerabilities. So when you CE mark your product, you're going to basically attest that there are no vulnerabilities in your software, which, for some people, is going to be a big ask. In the US, there's an executive order which has sort of been messed around with by various presidents since this was made, but it basically says you should have a software bill of materials for federal projects, otherwise you can't be involved in federal projects. And that might seem like a small sort of pond, but actually federal projects include all sorts of things, and you only have to touch a federal product to then be up for providing a software bill of materials. And you might say, well, actually, hang on, we did write all our own software. We know absolutely everything about it. Do you mind quitting that, James? Thank you. We know everything about our software. We don't need to worry about all this stuff about where did our library elements come from, etc. But did you write the compiler, for instance? Did you write the OS that your software is running on in that product? You still have to worry about all these things if you're going to make a declaration that there are no known vulnerabilities in your product. And going on to sausages, which is the next logical step from soup. So Ollie Whitehouse, the CTO at NCSC, recently said that we probably know more about what's in our sausages than is in our software, which in a lot of cases may well be true. Now, as I don't know, but many people in this room may already be in regulated industries like payments. My background, and of course in payments, we've been sort of worrying about this stuff for quite a long time, because in payments you have to jump through a lot of hoops to get your product certified. Same in medical device world. If you want to get FDA approval or EU compliance for your product, you're going to have to provide certain guarantees about your software integrity. And there's a nice sort of link back to soup. So one of the medical device IECs mentions soup as software of unknown provenance. And that's sort of, before we get on to actually the TAIBOM project, and the other thing is, just in case we forget about it, is that the EU are also going to make, for the first time, software part of the liability directive. So as of the end of December 2026, liability rules will apply to software as well. So unlike now, where you can pretty much say, it's a bit of software, we'll fix it in the field, they're going to say, well, hang on, that bit of software caused harm. It may have injured someone, or it may have caused financial loss, or it may have caused reputational damage, and it'll come under the same criminal legislation, regulatory legislation, as the rest of the EU Product Liability Directive, in the same way as if your toaster burns down a house, which has caused a lot of interest in the software community. So anyway, moving on to AI systems. So as we know, traditional software, we've got a big executable, we've got a relatively small config file, and we've got some well-defined behavior, probably. The bit of software does this. It's easy to test. You check whether it does that or not, and it complies with your your functional specification. In AI, of course, we've got almost the opposite. We've got a relatively small executable and a vast quantity of data, where the behavior of the system is largely data driven. So depending on what the training data was, depending on what inferencing inputs you give it, that determines the functionality in terms of the output more than the actual executable. And then in the same way as we might want to sign software when we distribute it to make sure that we're integrity checking it and we're only loading software into a system that we know where it came from, we might well want to do this with data in AI systems as well, but then we've got the vastness of the data to cope with. So can we do that quickly? If it's terabytes or petabytes of data, there's an integrity checking issue with vast amounts of data to resolve. So that sort of brings us on to the project I was talking about. So this Trustable AI bill of materials, and this project, which is a UKRI funded project, is really to do with standardizing some way of making claims, and partly it's the composition, so in the same way as software bills materials, but it's also a way of making claims and attestations about what's in a system, both the software and the data, and also at least attempting to solve the integrity issue. So we built some tooling for this. Inquiry Minds have done some tooling development on this, and that allows us to make part of that tooling allows us to make things like claims about who made the software, what was it made, what standards was it made to, statements of compliance, how well does it work, did it successfully pass a pen test, all that sort of stuff. And the sort of people who can make these claims are, of course, the creators of the data, so they might make data claims. Developers of the code may make claims about what their software can do, and even another AI agent may make a claim about an AI system, saying that I've done some testing, a bit like we were talking about before. An AI system has done some verification testing on an AI system, and has said that it passes some test or other. So coming on to use cases, one of the use cases, this is primarily driven by people like British Aerospace, is of course things like this. So they were very concerned about what was getting put into systems on their platforms, and especially now that they were going on to to be using AI systems more and more in battlefield areas, but we'll start talking about that. So instead, we're going to talk about 17th century shorthand, which is pretty much similar thing. And this is a use case that our partner Copper Horse was interested in, and talks about at our Bletchley Park event. So the CEO of Copper Horse is very, very interested in 17th century shorthand, and in particular the shorthand that was used to write Samuel Pepys's diaries, and also some of Isaac Newton's notebooks. And the interesting thing about this shorthand is that originally, when this was sort of discovered, it was assumed to be some sort of code, right? So the assumption at the time was, Samuel Pepys and Isaac Newton all wrote in some weird code that stops deciphering what they were talking about. But actually, it was written in something called Shelton shorthand, which was pretty common at the time. But of course, the sort of people who would be able to write it were relatively limited. But the interesting thing is, of course, that there's vast amounts of this writing, some of which still hasn't been deciphered. And Copper Horse are in the process of working with people like the British Library and the Bodleian Library to start deciphering more of the Shelton shorthand material. But it brings up some of the sort of fundamentals from the TAIBOM project. So, who owns that data? In some cases, it's a library. How accurate is it? What's the provenance of it? And then with the multiplicity of shorthands, even though people were writing in Shelton shorthand, of course, different shorthands were used by different people. Then modified them, made their own sort of variants of them, and that led to, of course, then having to use something like AI to try and pull those all together. So TAIBOM is able to do things like, for instance, provide some assurances about the origin of the data set, so we can make claims about the data set. We can make attestations about the data licenses that are allowed to use this text by the Bodleian Library, for instance. We can provide reasonable guarantees of integrity by using cryptographic signing of the data, and we can do things like peer review attestation, saying this, this data was, the provenance is known, but also this is being reviewed by someone else who agrees that the provenance is correct. So there are lots of, attestations you can make. And also, yes, so that was really to do with the TAIBOM project. But we're also at TechWorks working on a best practice guide for AI systems, and also working with DCIT on something called Model Cards Plus, which is sort of an enhanced version of the Google Model Cards, which government in particular is keen to take a look at in terms of public procurement. And the intention is to sort of build these into some sort of potential standard. We're talking to people like the IEEE, ETSI, about perhaps coming up with a standard which will incorporate these into one framework, which could be used for some sort of self-certification scheme. So on that note, if you're interested in joining TechWorks-AI, please talk to me. I'm around and downstairs. TechWorks-AI is the sort of AI part of TechWorks. If you are interested in joining the TAIBOM project, please get in touch. We were always looking for people to join it. We've got quite a diverse set of people in the project already, but more the merrier, really. And especially if you've got interesting new use cases. And last but not least, on the 30th of October at the IET in London, we've got our annual conference on resilient IoT and trustable AI. That's a great place to network, meet people who are in the IoT space and in the AI space, and many of our members will be there. That's it from me. Thank you very much.